All right, we're back. Let's do this. Let's learn about the law of conservation of energy by reviewing some of Newton's laws and looking at a concept that we call energy transfers. So on your science notebook page, you should title it the law of conservation of energy. You should include a definition and also include some diagrams to support your definition. All right, let's get started. So we've already recorded Newton's first law, second law, and third law. But when you look at energy transfers and the law of conservation of energy, it's important to review these two laws of motion, the first and the third law. So the first law of motion says that an object at rest will remain at rest, and an object in motion will remain in motion unless it's acted upon by an outside force. Now, as we talked about in the Newton's law video, an object in motion, as we see it here most of the time in our everyday life, an object in motion eventually stops. But that's because of those outside forces. That's because of friction. So we're going to talk about how the energy that was in that object is actually transferred, and that's why it actually stops. Newton's third law of motion states that when one object exerts a force on another object, the second object exerts a force on the first object. So basically what that means is that no matter what we do, whenever we interact with any other object, or when one object interacts with the second object always interacts with the first. That both things have to interact with each other in a system, that everything is connected. So let's discuss these two laws and talk about energy transfers. So essentially, what we're looking at is that no matter what, energy is always transferred from one form into another. So here, if we have a red ball on a smooth surface, we have motion energy. Now this red ball will kind of roll down this path, and it'll roll for a while until it eventually stops, and it will eventually stop somewhere down the line here on this nice smooth surface. And even though it's a smooth surface, it will eventually, let's say it's in motion here, and here there's no motion. So why did it stop over time? Well, it stopped because this red ball is interacting with the surface, and that surface is creating friction. Now, even though it's creating friction, what basically happened is that motion energy, the energy, got transferred into the surface. And so the surface was stealing some of that energy as the motion occurred until there's no energy left and there's no motion. So if we have motion here in a ball that's on the grass, say it's the same amount of motion, well, the motion energy is going to be transferred into the grass. The grass is going to steal some of that energy, and that ball is going to stop much sooner than it would have on a smooth surface because there's more friction. There's more energy transferred that then causes that ball to end up having no motion. So it stops. So here we have less friction, and we could also say less energy transfer. And down here, we end up with more friction. And if there's more friction, there's more energy transferred. Ran out of the page there. Now, let's talk about this red ball if it's up on a mantle here. So let's say it's lifted up off the ground. It's off the ground. So it has some type of energy, but it's not in motion. So right here, we would say it has potential energy. Let's just give this a value. Let's say it has potential energy of 4. Let's just give it a number here so we can show what happens to the amount of potential energy it has. Now, here there is no motion, so the amount of kinetic energy it has would be 0. But if we were to push this ball off of the platform, if we were to remove the platform and allow this ball to start dropping, this ball is still off of the surface of the earth. So it still has some potential energy, but it doesn't have as much as it did before. So let's say it now has potential energy 3. Well, this ball is in motion because it's falling. So let's say that it has some kinetic energy, but it just started falling, so it doesn't have much. So we'd say it has kinetic energy of 1. This ball, as it keeps falling, it's still off of the earth. It hasn't hit the ground yet, but it's in motion. It's moving faster because it's been falling for longer. So let's say now it's lost even more potential energy, and let's say it has potential energy of 2, whereas the kinetic energy has increased as well because it's been falling for more than it's fallen this far, much farther than it did before. So it has more kinetic energy than just 1, so let's say it has kinetic energy of 3. Now, here when it lands on the surface of the earth, it now has no more room to travel. So the amount of potential energy it has would be 0. And the amount of kinetic energy that it has, well, it's not in motion anymore, so it would also be 0. But what's important to know is that it had this certain amount of energy that no matter what, the energy was always changing. And if it started with potential energy of 4, then it should end with a certain amount of energy. It should end with 4 units of energy. So up here I need to change this value here, because the total energy in the system should never change. If we have 4 to start and 4 in the second step, we should end up with 4 in the third step. So we're going to say it has potential energy of 1, kinetic energy of 3. At the end it has potential energy of 0, kinetic energy of 0. Well, what happened to those 4 mystery units of energy? Well, what could have happened is that there could have been some sound energy when it hit the ground, or it could transfer that energy from the ball into the ground, and the ground could absorb that 4 units of energy. Okay, well, let's think about a bus let's say it's a UPS truck that's driving down the road and it's filled with packages. Well, when that truck needs to stop at a stop sign, it's going to slam on its brakes. So let's say here the potential energy that it has would be 0 because it's not in motion, or because it's in motion and it's on the ground. Let's say the kinetic energy it has equals 400. Well, over here, if it has no more kinetic energy and it doesn't have any potential energy either, it's just at a stop sign and stopped, well, we need to figure out where did those 400 pieces of energy go, because they have to go somewhere. So where did they go? Well, they probably went into some sound as the brake pads hit the rotors and caused the friction to occur. Also, it would have heated up the rotors as well, and so we would end up having some heat, and the brakes would get hot from using them. Maybe even the tires skidded on the road a little bit. If that were the case, then there would be more friction on the road, and some of that energy would be left in the skid marks as well. So even though the object is no longer in motion, that energy was there and now it's not. So we have to figure out, where did it get transferred to? So when we look at this concept, we can summarize it as the law of conservation of energy. So you can think about this word conservation means to save. So the definition for the law of conservation of energy is that energy cannot be created or destroyed. It will only change from one form to another. So it's easy to look at the difference between potential energy and kinetic energy. So let's look at it here with a swing. So let's say here that if we were to raise this person up and hold them up here at position A, they then would go down to position B, into position C, and keep moving to D, E, F, and G. So what we would notice is that if we hold them up at A, the amount of potential energy that they have would be the greatest. Let's say that they have 5. The amount of kinetic energy that they have would be 0 because they're not in motion. But as they fall, the amount of potential energy would decrease. So that would maybe be 4, and the amount of kinetic energy then would be 1, because the potential energy, even though it got lower, it got converted into kinetic energy. And then we could say at C, the potential energy equals 2, and the kinetic energy, let's say that's potential energy equals 3, kinetic energy equals 2. At D, we could say potential energy equals 2, and kinetic energy equals 2. Because the potential energy is constantly decreasing and converting it into kinetic energy. Well, what we would notice, though, is that as this swing got higher and higher up, it would start to slow down. So the amount of kinetic energy would decrease, which this should be 3. Got to keep my math right here, because it's always going to equal 5. So if we have kinetic energy of 3, as it goes up, it's going to lose its kinetic energy, and it's going to be higher and higher away from the ground. So it's going to gain potential energy. So here, potential energy would be 3, and the kinetic energy would decrease, so it would start to slow down, so it would be 2. At F, the potential energy would be even higher, so it would be 4, and the amount of kinetic energy that it has would be 1. Now at point G, this is where the swing starts to go backwards, so it no longer has kinetic energy because it's not in motion anymore. There's a slight moment where at G, this swing actually stalls. So it has potential energy of 5 and it has no motion, kinetic energy of 0. But then it's going to go back down and it's going to gain kinetic energy as it goes and returns back. Gain kinetic energy, lose potential energy, gain kinetic energy, lose potential energy, but then as it goes back up, it's going to lose some of that kinetic energy and gain potential, lose kinetic, gain potential, gain kinetic, lose kinetic and then gain some potential energy until it goes back and forth. And now this is why a swing will go back and forth over and over again, because the conservation of energy is not created or destroyed. It gets transferred from one form to another as that swing gets higher and higher off the ground, and then as it returns to its starting position. But we also have to think about the fact that some of this energy is transferred into the air because of the friction of the air will actually slow the swing. So if you were to start and just not pump the swing, you would end up stopping over time, and that's all related to the friction in the air as well as the friction of the top of the swing where the swing actually meets up with the swing set. So this is the law of conservation of energy. Energy cannot be created or destroyed. It will only change from one form to another between different types of potential and different types of kinetics. So we can even think about the fact like chemical energy in our food allows us to have kinetic movement energy. Or if we have chemical energy in our coal and natural gas that we burn, then we can have electrical energy in our home. And that electrical energy can create thermal energy in our homes and heat up our house. So no matter what, energy is not created or destroyed. It just gets transferred from coal to electricity to heat, or from food to motion to our bodies heating up. And so that is the law of conservation of energy.